Hello everyone, I am teacher Wang Xing. Today, let's continue to learn about air pollution control technology. Chapter 9, Section 6, Photocatalytic Oxidation Method, Control Vox Pollution. This class, let's learn the photocatalytic oxidation method together. This volatile organic compound treatment process. Firstly, the essence of photocatalytic degradation technology. It is an oxidation-reduction reaction carried out in photoelectric conversion. According to the electronic structure of semiconductor photocatalysis, when it absorbs an energy not less than its band gap energy photon time, electrons will transition from a full valence band to an empty conduction band, and leaving positively charged holes in the valence band. Valence band holes have strong oxidizing properties, and conduction band electrons have strong reducibility. They can directly interact with reactants. It can also interact with other electrons adsorbed on the catalyst, donor and receptor reactions. For example, holes can cause water to oxidize electrons, reduce oxygen in the air, generation of hydrogen peroxide, hydroxide groups, and water groups. These groups have strong oxidation ability, effectively oxidize Vox pollutants, ultimately decomposing it into carbon dioxide, inorganic small molecules such as water, to achieve the purpose of removing Vox pollutants. Let's learn about photocatalysts together. In previous waste gas treatment, mainly used are wide bandgap semiconductor photocatalysts. The principle of catalysis is the reaction between exhaust gas and zinc oxide, but there are few available photocatalysts, and at this stage of development, there are many types of photocatalysts, more widely used. Secondly, titanium-based catalysts. The main component is titanium dioxide. It can be divided into two types: composite titanium dioxide, doped with metallic and non-metallic substances, utilizing semiconductor coupling for waste gas treatment. The second is pure titanium dioxide, strong adsorption capacity, not prone to chemical reactions, capable of treating organic waste gas, but from the practical application of photocatalysts, still facing certain technical challenges. Further research is needed on photocatalysts to promote its volatility. Application in organic waste gas treatment. Principle of 2 photocatalysis. Photocatalytic reaction need to rely on high temperature and ultraviolet radiation to proceed. When the exhaust gas is exposed to ultraviolet radiation, start cracking reaction, convert oxygen into ozone. At the same time, the chemical bonds in the exhaust gas break apart to form functional groups. Chemical reaction between groups and ozone produce carbon dioxide and water. Due to this reaction process, occurring on the surface of the catalyst and using semiconductors can improve the redox reaction process, increase the light response performance within a specific wavelength. Then, with the help of photons, the reaction undergoes a change. For example, the principle of titanium dioxide catalysis, as shown in the right figure, after fully absorbing specific wavelength photons, promoting electron migration to the conduction band to form negative charge. Photogenerated electrons consume positrons on the borrowed band. The vacated position is supplemented by photogenerated electrons. Then, the organic matter adsorbed on the catalyst surface react. Practical application of 3 photocatalytic oxidation treatment technology. There is a problem of low light utilization. Titanium dioxide catalyst, widely used in organic waste gas treatment. It is more sensitive to ultraviolet radiation, but visible light is not utilized much, and the ultraviolet rays in sunlight are less. Unable to fully meet the needs of photocatalytic oxidation reactions, need to use ultraviolet lamps to improve light response. Increased cost of waste gas treatment. It will also affect the normal operation of related equipment, causing adverse effects. Based on the above reasons, further improvements are needed for photocatalysts, starting from visible light. Adjust the surface of the catalyst. Metal and non-metallic oxides can be used, or ion doping, to improve the photocatalytic activity of the catalyst surface, thereby increasing waste quality of gas purification. There are issues with inactivation and regeneration. First, let's analyze the reasons for the inactivation together. The cost of photocatalysts is high. Deactivation issues may occur in practical applications, like catalyst breakage and poisoning. The latter involves solid-to-solid reactions, etc. During the working process of the catalyst, need to continuously degrade organic waste gas, causing continuous consumption of oneself. So the degradation performance decline cannot be avoided, leading to inactivation issues, and the situation of inactivation is also different. For example, after the reaction between titanium dioxide and benzene, formation of carbohydrates, causing the occurrence of inactivation issues. Here are the regeneration methods. Photocatalysts undergo long-term degradation reactions, will accumulate a certain amount of material on its surface, and if these substances are not decomposed in a timely manner, long-term accumulation can directly lead to deactivation issues. Due to the current stage, the root cause of the inactivation has not been determined yet, so there is a certain connection between inactivation and regeneration. The commonly adopted solutions are oxidation and cleaning. The cost of catalysts is relatively high, need to be done during catalyst regeneration. Pay attention to cost considerations. The available regeneration methods include ozone injection and heat treatment, chemical regeneration, etc. The third is selective catalysis, chemical enterprises, the composition of volatile organic waste gas generated. Very complex, different enterprises. In this type of exhaust gas, the types and concentrations of organic matter vary. To ensure the effectiveness of waste gas treatment, enterprises need to consider the composition of exhaust gas. Choose the corresponding catalyst. For example, titanium dioxide performs well in treating toluene, and P25 photocatalyst can effectively degrade benzene. Classmates, through the learning in this section, basic understanding, the principle of photocatalytic oxidation method for treating VOX pollution, and its process flow. That's all for today's class. Thank you all.